Today we're going to learn how to divide rational expressions. Step 1. Factor the numerator if possible. Step 2. Factor the denominators if possible. Step 3. Take the reciprocal. This is where we will apply keep, change, flip. Step 4. Cancel common factors. Step 5. Write your answer. You're going to notice that the steps are very similar to multiplying rational expressions. We only have one extra step where we take the reciprocal. Let's take a look at example 1. On example 1, we have 3/5 divided by 27/5. I'm going to work out this problem using the same steps I would if I were dividing rational expressions. I'm going to factor my numerators if possible, and factor my denominators if possible. My 3/5 is already prime, so it's going to stay the same. I still have 3/5. I keep my division sign. I'm going to factor my 27. The prime factorization for 27 is 3 times 3 times 3. All over, my 5 is still prime. This is where I apply the third step, where I take the reciprocal. I'm going to keep my first fraction exactly the way it is. I'm going to change division into multiplication. And then I'm going to flip the fraction that is located behind the division symbol. So I end up with a 5 over a 3 times a 3 times a 3. Now we're going to put our fractions all together as one. And I can see that I have a 3 times a 5 in my numerator, and I have a 5 times a 3 times a 3 times a 3 in my denominator. Here is where I'm going to cancel my common factors. 3 in my numerator and a 3 in my denominator. I have a 5 in my numerator, I have a 5 in my denominator. Now that I've canceled my common factors, I can go ahead and write my answer. In my numerator, I have no factors left over, so I put my imaginary 1 back. Over, in my denominator, I have the factors 3 times 3. When I multiply those, I get a 9. So my final answer would be 1/9. Now let's take a look at example 2. This is a little more complicated than the example we did previously. The first thing I'm going to do is do my prime factorization of my numerators and the prime factorization of my denominators. So if I do the prime factorization for 8x squared, I end up with 2 times 2 times 2 times x, all over 3. My division symbol is still there. I'm going to do my prime factorization of 7x. It is just 7 times x, all over. The prime factorization for 6 is 2 times 3. I'm going to keep my first fraction exactly the way it looks. So I have 2 times 2 times 2 times x, all over 3. I'm going to change the division symbol into multiplication, and I'm going to flip the fraction that is located directly behind the division symbol. So now I have 2 times 3 all over 7 times x. Now I'm going to combine my two fractions into one. I'm going to look at my factors in my numerator and my factors in my denominator. I'm going to cancel what they have in common. I have an x in my numerator and an x in my denominator. I have a 3 in my numerator, a 3 in my denominator. Once I've canceled my common factors, I can write what's left over. In my numerator, I have 2 times 2 times 2 times x times 2. This gives me 16x divided by 7. Here is my answer. Now let's take a look at example 3. In example 3, now we've gotten to rational expressions. We're going to follow the same steps that we were doing previously. This right here is not a fraction. I want to change it so that it is. So I'm going to divide this by the imaginary 1 that was. Now I'm going to follow the same steps I was doing before. I'm going to factor my numerators and then factor my denominators. Now for this first numerator, I'm going to factor using MIFTERM. Pause here so you can factor. My factors end up being x plus 2 and x plus 2. In my first denominator, I have x plus 3. X plus 3 cannot be factored at all, but I am going to put it in parentheses so that way I know that this x and this plus 3 are linked together. I still have divided by, and I have my x plus 2 in my numerator, which is unfactorable, divided by my 1 in my denominator, which is also unfactorable. Now I'm going to apply the third step where I take the reciprocal. I'm going to keep my first fraction exactly the way it is. So I have x plus 2 times x plus 2, all divided by x plus 3. I'm going to change my division symbol into multiplication. And then I'm going to flip the fraction that is located directly behind my division sign. So I end up with 1 divided by x plus 2. Once I have my fractions fixed the way they needed to be, I can go ahead and combine these into one fraction, and I can cancel the factors they have in common. In my numerator, I have an x plus 2, and in my denominator, I have an x plus 2, so those two factors will go. Now I can write my answer. In my answer, I have an x plus 2 times a 1. That leaves me with an x plus 2. All over. In my denominator, the only factor remaining is my x plus 3, so I can write down x plus 3. This is my answer. Let's take a look at example 4. For example 4, we have a problem, and it looks a little complicated, but we're going to perform the same steps that we were doing before. We are going to factor our numerators and factor our denominators. Let's factor our first numerator using MIFTERM. Pause here so you can factor. My factors are 2x minus 3 and x plus 1. Now I'm going to factor my first denominator using GCF. You can pause here so you can factor. My factors are 2 parentheses x squared plus 4 divided by. Now I'm going to factor my second numerator using MIFTERM. You can pause here to factor. My factors are x plus 2 and 2x minus 3. Divided by. Now I'm going to factor my second denominator using GCF and difference of squares. Pause here so you can factor. My factors are 2 parentheses x plus 4, x minus 4. Now I'm at my third step where I will take the reciprocal. I'm going to keep my first fraction exactly the way it looks. Now I'm going to change my division into a multiplication sign. And I'm going to flip the fraction that is located directly behind the division symbol. So I end up with 2 parentheses x plus 4, parentheses x minus 4, close parentheses, all divided by x plus 2, 2x minus 3. Now I'm going to combine my fractions into one, and I'm going to cancel out any factors they have in common. I have a 2x minus 3 in my numerator and a 2x minus 3 in my denominator. I have a 2 in my numerator, I have a 2 in my denominator. Those are the only factors that I can cancel out. My answer is x plus 1, x plus 4, x minus 4, divided by x squared plus 4, x plus 2. It seems complicated, but this is our answer. For our last example, this one looks very complicated because now we have 3 fractions that we are. Don't let this one overwhelm you. We are going to do the same exact steps that we were doing before. I'm going to factor my first numerator using MIFTERM. Pause here so you can factor. My factors are x plus 1 and 2x plus 3. Divided by. I'm going to factor my first numerator using MIFTERM. You can pause here so you can factor. My factors are 2x plus 3 and x plus 2. I'm going to factor x cubed plus 1 using sum of cubes. You can pause here so you can factor. My factors are x plus 1, x squared minus x plus 1. Divided by, I'm going to factor my second denominator using difference of squares. You can pause here to factor. My factors are x plus 2, x minus 2, times. I'm going to factor x squared minus x plus 1. You can pause here to factor. If you try to factor this, you would see that it is prime. There are no two factors that we could multiply together to get x squared minus x plus 1, so I will leave it alone. I'm going to go ahead and put it in parentheses so I know I tried. Divided by, I'm going to factor my third denominator by taking out the GCF. Go ahead and pause here to factor. My factors are 2 parentheses x minus 2. Once I have factored my numerators and my denominators, I'm going to take the reciprocal where needed. I'm going to keep my first fraction exactly the way it looks. So I have parentheses x plus 1, parentheses 2x plus 3, all divided by parentheses 2x plus 3, parentheses x plus 2. I'm going to change my division symbol into multiplication, and I'm going to flip the fraction that is located directly behind the division symbol. So I end up with an x plus 2, x minus 2, all over x plus 1, x squared minus x plus 1. And then you'll notice that the third fraction is behind a multiplication symbol, so we don't do anything to it, and we end up with x squared minus x plus 1, all divided by 2 parentheses x minus 2. Once we've factored everything, we can put our fractions together as 1, and we can cancel the common factors. In my numerator, I have an x plus 1, and in my denominator, I have an x plus 1. In my numerator, I have a 2x plus 3, and I have a 2x plus 3 in my denominator. In my numerator, I have an x plus 2. In my denominator, I have an x plus 2. In my numerator, I have an x minus 2. In my denominator, I have an x minus 2. In my numerator, I have an x squared minus x plus 1. And in my denominator, I have that same x squared minus x plus 1. Once I've canceled all the factors they have in common, you'll notice that we have no factors left in our numerator. So we have to put our imaginary 1 over. And in my denominator, I canceled everything except for that positive 2 right there. So I have 1/2. So my answer is 1/2. Thanks for watching. Now you know how to divide rational expressions.